Good morning, good afternoon, good evening, whenever and wherever you are. My name is Anna Rochelle, and today's video looks a little different. What we're going to do is we're going to go ahead and take a look at some questions from the Big Ideas Geometry textbook. This is the chapter on circles. I want to say that it is chapter 10. It is. This is chapter 10, section 6. And this time it's a little bit different because I actually have a specific thing to share with you because I figured it would not be a great idea to do all of these circles, to draw all of them. So I just decided to take a screenshot and put it all in. So what I am going to do is I'm going to move some stuff around on my computer and then we're going to get started. Okay. So the general idea of these circles and these secants and tangents and chords and things of that nature is what's going to happen is we're going to create some sort of multiplication piece. So we're going to take the outside of the line and we're going to multiply it by sorry, not by the inside, by the total line. Okay, so the outside of the line times the total of the line should equal the outside of the other line times the total of the other line. What do I mean by this? So if we're going to take a look at problem 7, I know that I have an outside portion, which is starting from here to here, that's the 6. And then I have the total portion, which starts from here and goes all the way, the whole way is 16, right? I also have the other line that kind of goes in this direction. The outside portion is 8, and the total portion is going to be x plus 8. You know, I got this 16 because I know that this portion is 10. I got this x plus 8 because I know this portion is x, right? So here's kind of where we're at. We're going to take 6, multiply it by 16, and set that equal to 8 times x plus 8. I'm going to go ahead and multiply things out. So this is what? 96 equals 8x plus 64. Subtract 64 on both sides. I'm going to get 8x is 32 and x will be 4. I will continue to do the same exact thing every single time. Problem 10 is kind of like a nicer problem because they give me the whole already, so I don't have to add or subtract or multiply or divide anything. I do want to do problem 9 in here because I think the student who sent these in said it's only odds, but who knows? So if we're taking a look at this one, this line has 4 on the outside, right? And then I have a total of 9 as a whole, right? And I got the 9 because this portion is 5. The other line is the outside portion here is this x minus 2, and the inside portion is this x plus 4. So in order to get the entire line, I'm just going to do x minus 2 plus x plus 4 so that I get the full line all the way across. And in this case, I can combine like terms and I can get 2x plus 2, right? Because x and x is the one term, and then negative 2 and positive 4 is another like term. So I'm going to go the outside of my line times the whole line equals the outside of my line times the whole line. Whoops, that's supposed to be 2x. And then in here, I'm going to go ahead and distribute. So I'm going to get 2x squared plus 2x minus 4x minus 4. I know that these are both like terms, so I'm going to get 2x squared minus 2x minus 4. And all of that equals 36. I'm going to subtract 36 from both sides. So I'm going to end up with 2x squared minus 2x minus 40. I can divide everything by 2 before I go in and factor. So I'm going to get 2x minus x minus 20 equals 0. And then I can go ahead and factor this out. So I'm going to end up with x times x is x squared My factors of 20 that add up to -4 are just, sorry, -1 are just -5 and +4. And when I set each of these equal to 0, and let me go ahead and erase this whole bit over here. Yikes, that's a lot of erasing. Doo-doo-doo. Okay, so when I set each of these equal to 0, I end up with one number that's negative and one number that's positive. So this will be x is 5 and this will be x is -4. I would recommend checking both. Sorry, that's supposed to be -4. If I plug in -4 in here, that means I'm saying that this distance here, like this whole distance here, is going to be 0, right? Because -4 plus 4 is just 0. And then this distance is going to be negative, and that's not okay. That's not a thing. So what I'm going to do is I'm going to reject that answer and say that my only possible answer is x is 5. And that's kind of where we're at for that particular problem. The other two problems are exactly the same, with the exception of, hey, I have an entire piece that is outside, and the outside is the total, right? So I'm still going to do the outside times the total line, except in this case, the outside is the total also. So for example, in problem 11, I'm going to do x times x because it's the outside times the total, and that's going to equal to 9 times 16. So I'm going to end up with x squared is 90, 50, 144. And then I'm going to find the square root of both sides. I'm going to get x is equal to 12. And then that'll be my final answer for that particular piece. The same thing is going to happen when we look at problems like problem 12. I'm going to end up with 24 times 24 because that's the total times the outside. And then that's going to be multiplied on the right-hand side. I'm going to have the outside is 12 times 12 plus x, or x plus 12. One thing that I can do if I don't have access to a calculator for these problems in order to make my life a little easier is I can divide both sides by 12. So if I divide this side by 12, that just cancels. And if I divide this side by 12, I get multiplied by 2. So I'm going to end up with 48 equals x plus 12. And then I'm going to subtract 12 on both sides to get x is 36. And then that would be my final answer. If I take a look at problem 13, and now you can absolutely go in and try some of these on your own. I don't see why not before I do any of them. So my outside is x plus 4. My total is x plus 4, so I'm going to have that out here. And then in the other line, my outside is x. My total is x plus 12. In here, I can't simplify anything like I did here. So I'm just going to have to go ahead and distribute everything. So I'm going to go x squared plus 8x plus 16 after I distribute and combine like terms. And then here I'm going to have x squared plus 12x. I'm going to go ahead and combine everything. So I'm going to subtract x squared from both sides. That'll cancel. I'm going to subtract 8x from both sides. That will cancel. And I'll be left with 16 equals 4x. So then I divide by 4. X will be 4. Now, one of the things I do want to make sure that you know is that anytime you have any sort of factoring problems, the expectation is that geometry students do understand these factoring problems. And so if you need help, I will link in here my playlist for factoring so that way you guys can see that. Problem number 14 is the same exact thing. Do not let that square root scare you. So I have root 3 times root 3 is going to equal x times this x plus 2. Root 3 times root 3 is just root 9, and square root of 9 is 3. And then when I distribute this across, I'm going to end up with x squared plus 2x. I'm going to move the 3 over to the other side, and then I'm going to have to factor. And when I factor this, I actually end up with a very similar type of problem like I did with problem 9. So x, and then I'm going to do plus 3 minus 2. I'm going to set each of these, whoops, not minus 2, minus 1. I'm going to set each of these equal to 0. And I'm going to see that x in here is a negative 3, which is not allowed because then this whole bit right here would just be a negative number. So I'm going to reject this right away. And I'm going to say that here x is 1. I hope that this was helpful, and I'll see you in another video. Bye.